So today we move into polynomials. What does it mean, and actually I'm going to skip this since we've spent so much time passing out papers. What does it mean for something to be a polynomial? What does poly mean? Jacob? Many. Nomial? Yeah, numbers are things that represent numbers or terms, something like that. Pearson has been really acting goofy today.
I don't like her.
Doesn't want to load anything. We can just walk through your notes if we need. Let's just start here. So, polynomials means just many, or, it can mean singular. A singular polynomial would be a, it's singular. What? Monomial. So one, mon means one. So when we're talking about degrees of polynomials, what do you think we're talking about? The degree of a polynomial. Like if you look at 5x, the degree of the polynomial. I maybe didn't put all the key concept things on here.
You did not.
I wonder, because I want to show them to you guys and get them in the Schoology notes. So I really wish that this was working today. Oop, maybe. If I force it, nope.
The one day that
I'm going to try one other thing. I don't think I can get to it this way.
Upgrading to Windows 10 soon.
This is not really technically my computer. So
Mr. S is it. Mr. S is Mr. S.
that's his computer.
Oh, really?
Yeah. Haha, I win. There's always a back doorway in. And actually, when you guys see my computer, when I'm recording, it's in a really basic color scheme setting for the recording.
It is?
Yeah.
Meaning?
Are you recording right now?
Yes. So when we talk about the degree of a monomial, we're looking at the exponent of it. So the exponent on a monomial, pretty easy when it only has one variable. So our degree for 5x is just 1. So I would on your notes write like it is the degree of the expression because it's not an equation. So now the question becomes when we have 6x, so it's just 1 because the degree was 1. The power on the 5x is really 1 because it's really 5x to the first. Now the question becomes when we have, I hate these little old arrows. Okay, well it already gave it away because I keep clicking too many. When we have a monomial that includes multiple terms, to find the degree, we add the exponents. So when we have a third and a second power, we add up the 3 and the 5, and their combined degree is 5. So then, 4. What do you think, Seth? 0. It has no power on the variable. So when we deal with these, and I should actually go back and capture, it's always the power of the variable.
Oh, that's helpful.
Because every number is always just to the first power. Unless we want to rewrite it in a different way, which then is just re-expressing the expression. There are some things about the Pearson upgrade that I do like, and how you select through the lesson is definitely one of them. So try the got it. You have 8xy. Raider, what do you think?
I just have a question.
Okay.
So if you just had like x times y, would it be 2 then?
Well, with 8xy, that's essentially what you have. You have 8, which is to the degree 0. X has a degree 1, y has a degree 1, so our combined degree,
I didn't actually look.
yeah, is just 2.
Oh my.
So exactly what Raider said, 8xy is really like 8x to the first, y to the first, so our degree is 2. Pretty straightforward.
It looks like a line coefficient.
Huh.
I'm guessing it's going to go.
I know the answer to the next.
Okay, let me get there. When it's not even on the screen yet. Alright, so now we get into like terms. And obviously that we always start with review and then we get harder. So 3x squared and 5x squared are like terms, but why? What makes them like terms? Leah?
Because they're both x squared. It's just their coefficients just say how many.
Yeah, coefficients are kind of irrelevant when looking for like terms. There are two things like terms have to share. They have to have the same, and you already said one of them.
Same base.
Same variable, so kind of like base.
Same degree.
And then same power.
Yeah.
So, like terms, you're always looking for same, now I want to say base. Same variable, same power. So here when we combine them, what's the sum? 8x squared, right? Because you have 3x squared plus 5x squared, you get 8x squared total. What about the next one? This one gets a little bit more challenging. We have 4x cubed y minus x cubed y. Are these like terms? Yeah, right? Because now, and this is what I was trying to explain to my 7th graders today. When we put multiple variables together, it essentially creates a new variable. And you'll do this as you get further up in your mathematical career. You can kind of think of x cubed y. We could call that some new variable z. So this is really 4z minus z. How many z's do you end up with? 3. So we really end up with 3x cubed y.
Wow, this is confusing.
What's confusing about it?
Life in general.
You just complain into complain?
No.
Okay, I get it. Exactly.
I don't get it, but I don't get what part I don't get.
Let's go further and see if you can identify what doesn't make sense. Jacob?
A lot of times when you're doing fractional linear equations, setting a variable for like each fraction really helps. Like,
Yeah, I know. Yeah, I know what you mean. It would make more sense if we had an example to show it, but. All right, try these on your own. You have a sum and a difference. Sum involves a -6 first, so be careful. -6x to the 4th plus y to the 4th. Grant, I'm going to pick on you just to try to see if I can help you understand better. So are these like terms? Do they have the same variable to the same power?
Yep.
Yes. So for a moment, forget about those variables. What's -6 plus 11? And since they have opposite signs, really find the difference. Yeah, so it's 5. So then when I combine them, it's just 5x to the 4th. That's all we got to do. So because they have like terms, you can momentarily forget about the variables and just combine the coefficients.
Okay.
So then, Emily, did you have your hand raised?
No.
Okay. So then, when we move on to the difference, 2x squared, I can't find your guys' class.
-5x squared y to the 4th.
Yeah, Grant already gave it to us. But yeah, -5 and then x squared y to the 4th, because we identify first that they are like terms and then just combine the coefficients. Any questions for all of part 1 or part 2?
Okay, that makes sense.
Okay, time to step it up.
Um,
So now we have to classify polynomials. Write each polynomial in standard form. What's the name of the polynomial based on its degree or number of terms? Now when we talk about standard form, well, what does standard form really mean? Standard form is just talking about putting them with the higher power first. So when we start getting into trinomials and the quadratic function and everything, you're going to be used to seeing something that looks like ax squared plus bx plus c, because this has degree 2, this has degree 1, and this c really has degree 0. So standard form is just writing them in order of degree. So this is technically what we call a quadratic binomial. Because it's got a 4x squared, that would create a parabola. Anyone know what the 4 would do to it? It does not move it up, actually. It changes the steepness of the graph. So a standard parabola, x squared, has a standard slope. 4x squared would either, and we'll go further with this, but I want you right now to just kind of leave it thinking. 4x squared will either bring it in together or bring it out wider to the parabola. And then the 3x has its own shift that it does to the parabola also. I need to make sure that I'm capturing these. So, when you go to try to write b in standard form, order that by the degree of the exponents. And simplify if possible, which here, yes, it's possible. Seth?
For the parabola, how high would you have to go to even out the parabola into a straight line?
It never becomes straight.
Oh.
It's a very mathematical one. It really doesn't. It will look like it becomes straight, but there will always still be a slope to it.
Be a very steep one.
Yeah, it'll become so steep at some point that it'll be very, very, very difficult to define, but it never actually becomes undefined.
It's like trying to define pi.
Yeah.
It keeps on going.
So what can be combined here when we look at simplifying?
4x
4x
and 7x.
and 7x, right? I have those as my like terms. So when I combine those, I automatically know that my x is really 11x. So then when I order these by power, what should come first, Ben? 5x to the third. Now plus 11x minus 1. Questions?
Nope.
Exactly.
And that would be a cubic, because it has something to the third power. Trinomial, because there's 3 terms. So anything that has a variable squared is quadratic. Anything that has it cubed is a cubic. And actually, this gets into the really cool stuff that we can graph if you have one of the TI-83s. A cubic would graph like this. It kind of has a parabola that goes down and a parabola that goes up, and they merge in together. Cubic graphs are real fun. Did that capture? No, it did not. I always hated that slide between. Now it's your turn. That's a pointless slide. You guys don't even know what I'm talking about.
Yes, I do.
This slide.
Can you
What's the point of that slide?
read the audio?
It doesn't have an audio. It just dings,
But
which
then
is more annoying.
You like know it's your turn though, because like it looks different.
All right, try it on your own. Standard form, combining like terms possible, write in order of the degree.
Wait, is it my turn?
Oh, Greg.
I never saw them.
Ow.
And then name it. What is this? Is it a binomial, a trinomial, quadnomial? Emily, what does this become? Now I'm using cards. When I write this in the correct way, how do I reorder these?
Oh, it's 8x squared plus 2x minus 3 and it's quadratic trinomial.
It's quadratic because the power of 2. And it is a trinomial because there are 3.
Oh, I didn't know that was two quadratic. I thought that would be at 4.
No. Yeah, that is misleading.
Quadratic is the
I said binomial.
Quadratic is squared, yeah.
So can you simplify this at all?
yeah. I was thinking.
Can I what? This one can't be simplified. There's no combining.
What's binomial? Binomial is obviously. Well, no, I know.
Wait.
Quadratic.
So there's really nothing before quadratic because it's linear. Because if you only have, like say we didn't have the 8x squared, then it's just a linear binomial. Does that make sense?
Yeah. Well, so is it just quadratic?
Quadratic and cubic is normally the you can go higher, but those are really the only ones that are practical for our use. Oh, work with me.
In this problem, you will add polynomials. The number of overnight stays in thousands in U.S. Park Service campgrounds and in the backcountry of the National Park System.
So we're looking at a population of animals.
What do you know?
No? Yeah, overnight stays.
Please
We're
excuse
not
the
to animals
interruption.
yet.
Could I please have Nicholas Rumpler to the office, please? Nicholas?
We have some really cool names in the 7th grade, like Rompler and Schwarzwalder.
Who's Schwarzwald?
We got
Raiden?
some Germans in here.
Oh really?
So, Number of overnight stays in thousands. So guys, a lot of times when they present data, hey Greg, I'm up here. A lot of times when they present data, it'll be in hundreds or thousands or millions. And actually a friend of mine, have I talked about Randy in here? He's an architect. He's finishing up his degree at Franklin. They were just doing a project. It was a group project. One of his group members did not realize that the table they were using was in millions. He thought it was in millions. The table was actually programmed to be in thousands. So when he typed the numbers in, he thought they were all going to be multiplied by a million. So he put like 2.4, 3.7, thinking that would be like 2,400,000. It really ended up being 2,400. Huge mistake. They literally lost millions of dollars because the product differences. So you got to know what you're talking about when you're in a scale. So this scale is dealing with in thousands. Huh? He was very mad at his group partners. So they recovered though. They made a bunch of profit the next quarter. It's like a big business simulation.
Oh.
Oh, it's a simulation.
Yeah.
Okay.
Sorry, that's probably an important detail.
like,
Yes, they lost
why?
millions of dollars in their simulation.
I was like, why would
Yeah.
they let like college students like lose millions of dollars?
That's why you do simulations.
I'm sorry for the interruption. Could I have, please, to the office, Camellia?
Can we
Camellia,
like
to the office, please?
quicken up these announcements? Couldn't we just say Camellia, get here? All right, so we want to combine these to talk about combined campground and backpacking. How many people stay? So all we can do here is combine our like terms. So we can say together or something like that. So what can we combine between the campgrounds and the backcountry? And the reason this starts negative is how the parabola would have to look. Greg?
So you can combine the ones without any variables, just like the 5.
Oh, the constants? Yeah, we can combine the constants.
Can I go on?
Well, what is the sum of those constants?
7,000.
Not quite.
What?
Yeah, I'm joking. 7,700, right?
I'm really scared.
Not quite.
Can I not math?
Essentially add 2,000, then come back 100. So we have 7,700 will be at the end. Mackenzie, what else can we combine?
The 21x squared and negative 7.
Yeah, so the 21x squared and the negative 7.1x squared, essentially that's going to be like a difference. What do you get when we do that?
13.9.
13.9 x squared. And Leah,
Yes.
what else can we combine?
The 180x and the 140x
Yeah.
would be minus 40x.
Ooh, since
Oh,
they're
would it?
both negative,
Oh,
we
then
add them and then we keep it negative. So it's actually going to be negative or minus 320x. I want that. Okay, that plus was just too close for me. Questions on how we combine this?
So we just add them when combining?
Always find your like terms, put them together. So now we have a quadratic trinomial. Come on.
What is it called if it's to the third power?
Cubic.
One. First, add terms with x squared.
A quadnomial. But that starts to get bad. Yeah.
Then add terms with x.
It'd be a
polynomial that models the number of stays in thousands in campgrounds and backcountry over the 5-year period is 13 9/10 times x squared minus 320 times x plus 7,700.
because we make things complicated. That's what we had, right? 13.9 x squared minus 320x plus 7,700. Try the got it on your own. Consumption of carrots.
than you actually get from eating it.
Right, because it's primarily water. Should be combining this on
The truth.
Should be combining this on to identify like terms. So anything that shares same power to the same exponent. So notice that tall x cubed. There's nothing else with cube down here. So we just
Discuss this.
yeah, then those can combine. Exactly.
Would this be called quadratic?
Yes. Yeah.
Really, after 3, we just call it a polynomial because it gets messy.
Pentanomial.
Monomial.
Wait, what happens if it's quadratic? Cubic.
Oh, it would be pent or pentanomial.
Cubic quadratic.
It can be penta
It's a pentanomial.
because pentagram,
Yeah.
or pentagon.
Penta sounds better too.
What, like, he said, like,
Oh, there it is.
cube and quad.
Are you serious? Come on.
No, I
Oh,
have
your
I
answer
did.
right up here.
Yeah.
Get to work.
We call it a cubic.
We just call it a cubic polynomial. I mean, you could call it a quadnomial. Yeah, you call it by the biggest index. So since the biggest index is 3, it's cubic. All right, most of you, I believe, have your answers. So you should have negative 12x cubed. It did not have a like term to combine with. I combine my 106 and my 14, and I get 120x squared. I combine my 241 and my 14, both negative, so they become 255x, but minus 255x. And then we combine the 4477 and the 1545 to get 6022. Questions on this?
What is it called? Cubic quadratic.
We just call it a cubic polynomial.
On the test,
Yeah.
are you gonna want us to write down what it's called?
Not necessarily. I might ask you, like, on one of them, identify what this is, and then you'd have to know.
Are we going to have less than 40 questions on the homework?
I'm not certain because actually I still need to run your homework. They're not back from the copy center, so I got to go make them.
I'll go make them.
Oh, you're welcome,
If I had taught you how to work the copy machine, I wouldn't really have a problem with it, but I can't really. Okay, now I'm really.
All you have to do is attach.
In this problem, you will subtract polynomials.
Here's where the common mistake
What is a
happens.
simpler form of the quantity x cubed minus 3 times x squared plus 5 times x minus the quantity 7 times x cubed plus 5 times x squared minus 12?
So I take each of these and kind of like this is mentally what I'm doing. X cubed minus 7x cubed. Then I'll do negative 3x minus the 5x. Or sorry, negative 3x squared minus the 5x squared. So working one at a time. X cubed minus the 7x cubed. What x cubed do I have? Negative 6, right? My negative 3x squared and my minus 5x squared leaves me with minus 8x squared. And then our 5x minus, well, there is no other, just x. So it doesn't get subtracted by anything. It just stays 5x. And then we can do minus a negative 12. So it becomes plus 12.
Wow.
Just so your eyes can see it. Beautiful. Try the got it on your own because this is where people make mistakes. Try the got it on your own. Avoid your mistakes. Hey Greg, now it's your turn.
Now it's your turn.
Just Greg's turn. Do I have to do it too?
I mean, I don't know why you're talking to me. I already knew it was my turn.
Most of it's pretty similar.
Okay, I don't think I did this right, but I think I might have done it right, actually.
No, there's then I have like 5 chapters in this entire section.
5 chapters?
Here, look. Wait, Mr. Hudson, how many sections are there?
8. We already talked about this.
Wait, that means 7 is an option.
Well, it's more than an option, but you said there was 5.
Right.
You're not actually going to take
See, Grant's like a massive.
You get disappointed when you get just
All right, what'd you guys get?
Negative 4.
-4m cubed.
minus 4n squared
Minus the
minus
form-
2n plus 21.
Yep, there you go.
21.
Ah, seriously?
I got that.